Hello, hello everyone. How are you all? I hope you all are doing a lot of hard work. So we have to discuss this particular set 5513 in this particular video. Section A, question number 1. Paper is difficult, moderate, easy. For average student, paper was moderate. For a student, hard-working student, paper was easy. Chal. Section A, a thin plastic rod is bent into a circular ring. So we have a thin plastic rod and the thin plastic rod is uniformly charged. It is written that it is charged, uniformly charged, having charge density lambda. Okay. Now why I'm taking positive? You can take any charge. Both the positive and negative will get the correct answer. Now this wire is bent into a ring. Okay. Then we have to find the electric field at the center of the ring. How we will find? Now let us try to understand. See, if you will see the chapter number 1 beta, the examples, you have a question in which there is an equilateral triangle and 3 equal charges are placed at the vertices of that particular triangle. So in that particular question, we found the electric field at the center was 0. Then in some reference books, you must have seen this particular question also, in which there is a square and on all the vertices we have equal charges at the center, electric field 0. Pentagon, hexagon, we have so many such symmetric shapes. So whenever we have a symmetric shape at the center, the electric field will be 0. So to understand this one, you can consider a little element here. Okay, I have considered positive charge. You can take negative also. The positive charge, due to positive charge at the center, electric field will be in this particular direction. And if I'll consider the just diagonally opposite element, then electric field will be in this direction. For that, but from because of that, this element, if you will consider an element here, electric field will be in this direction. Again, diagonally opposite element, electric field will be in this particular direction. All the lower half elements, electric field at the center is cancelling the upper half elements electric field. Yes, so electric field due to the lower half elements is cancelled by the electric field due to upper half elements at the center. The net electric field will be 0. Question number 2. 3 small charges Q, X, Y and Z. 3 charges X, Y and Z carrying charges. They are having charges plus Q. This one is plus Q and this one is minus Q and this one is again plus Q. Yes, are placed equidistant from each other. This distance is equal. You can consider it as A. As shown in the figure, the spheres X and Y are held in place. So X, Y and Z are held in place. So we have placed the spheres Y and Z in the place. They are fixed. Initially X is also held. But otherwise the X is free to move. X can easily move. So we have to find that when the X is released, what will be the path of the X, whether it will be this one, this one, this one or this one. That you have to check. Okay. To understand that, let us consider 3 charges placed equidistant from each other. X, not X. This one is Y, this one is Z and this one is X. Plus Q, this one was minus Q, this one was again plus Q. Yes. Now, if you will consider force, let us see the direction of force beta. Why? To see where this charge will go, we have to check the direction of force now. Net force acting on this X now. So negative charge, positive charge, attraction. Let's say the distance is A and the magnitude of the force is K, Q divided by A square. Yes. Similarly, this one and this one, positive repulsion. Let us find the magnitude. K, Q divided by distance is same. So you can see the force magnitudes same. I told you so many times that when you are finding the value of magnitude of force, no need to put the sign. Yes, sign is also only telling us the directions. So anyways, here, while finding the magnitude, we have not placed the force. We can easily see the magnitude is same, is equal. Directions we have already placed by using common sense. Okay, chalo. Now here you can see, if you are a 12th passed student, you can easily tell the directions. The net force will be in this particular direction. Yes, this will be the net force. Now by just finding this direction, you cannot mark that x will go in this particular direction. Just have patience and think about it again. So if we will consider the movement of x, so x start moving, let's say the x reached here. When the x reached here, beta, this distance and this distance, if you look, this distance will become smaller and this distance will become larger. Once this distance is large, we know that once this distance is large, this force will be small, and this distance is small, then this force will be large. So the net resultant will be somehow shifted in this particular direction. Yes. So initially the force was in this particular direction. As the x started moving, the direction of the force is turning like this. Accordingly, the charge will turn. Option will be B. Clear? Next question. Question number 3. In uniform straight wire, conduction electrons are moving in plus x direction. Okay, conduction electrons are moving in plus x direction. E and J be the electric fields and current density. Then we have to find the direction of electric field and current density. Again, simple question. If you will consider a wire and electrons are moving along plus x axis, then we know that very easily, if you have a positive charge here and a negative charge here, electric field will set up from positive to negative like this. And if you will place a negative charge here in this electric field, this negative charge will get attracted by the positive charge and will be repelled by the negative charge. Definitely it will move opposite to the electric field. Yes, in this simple way we directly say that negative charge always moves opposite to the electric field. It means electron movement this one, so electric field movement will be this one, opposite. Yes. Now from this electron movement you can easily see the direction of current will be this one. Okay, whatever is the direction of current, in the easy manner you can understand the same will be the direction of current density also, J. Yes, J is I by current upon area magnitude wise, but the direction wise actually it is J dot A is equal to current. This is the actual formula, but anyways NCERT only J is equal to I by A. Okay, you can, whatever is the direction of current, in easy way you can understand. If the area of cross section is perpendicular, if the area of cross section is perpendicular to the direction of J, then you'll get this formula. Okay, I'm not going into the depth of it, but anyways this will be the direction of J also, minus x axis. So B will be I, J, both are in the minus x direction, so B will be the correct answer. Very easy. Fourth question. Two charged particles P and Q, two charged particles P and Q, each having Q charge. Two charged particles P and Q, but masses are different, accelerated through the same potential. They enter in the region of magnetic field which is perpendicular to the velocity. Describes the circular path of radius A and B. You have to find the ratio of the mass. Now we know that whenever charged particle enters in the magnetic field and is perpendicular to the magnetic field also, then it will follow its trajectory will be circular. And the radius, we all know the formula, it is mv divided by qb. Yes or no? Yeah. mv divided by qb, you can write it as p upon qb also. But can we use this formula to find the ratio of masses? No. Why? Because velocities are not known. Two charged particles, each having charge q, but the mass is different now, so velocities will be different. So we can consider the magnetic field, let's say in this particular direction, and the charged particles are entering perpendicular to the magnetic field. So you can consider like this, the two charged particles. This is, let's say, the p charged particle and this is the q charged particle. Both are having the charge same, the q charge. Mass is m1 and m2. m1 mass, m2 mass, are accelerated to the same potential difference. Now this is important point. Potential difference is same. Yes, they are accelerated because of some potential difference applied by a certain battery. So battery will do some work, and that work will be converted into the energy. Okay, the kinetic energy they are having. because of which they are moving, na, their velocities at this particular instant we don't know, so I'm not considering the velocity also. We have to find the ratio of the masses. Now we cannot use this formula because velocities are not known to us, so we can apply this P wala formula. P is, this R value is P divided by QB, correct? Acha. Now understand carefully. We all know that this P, the energy, the kinetic energy is equals to half mv square. Multiply with m, divide with m. You will get half m square v square divided by m. Yes, you will get half m square v square is p square divided by m. This is the kinetic energy. So from here you will get the p square value as 2me. Clear? So P value will come out to be root 2me. So can we place it here? Why I am using this formula? Why I am using this formula? Because somehow I wanted my formula, in the formula, the potential difference should come. Why the potential difference should come? Because this is the value which is constant for both of them. Q is constant. So now I want to remove this velocity, because velocity is not known to me. So to remove the velocity, I'll convert this momentum, it's this P value, into root 2me. Clear? Chalo. Now E is the energy, na? How the charged particle got the energy? So many times in the theory I have discussed this thing. Okay, how the charged particle got the energy? Some battery somehow worked on the charged particle. Na? The work done by the battery can be given as charge of that particular charged particle into the potential difference applied. Yes. So now this V value, beta, potential difference, they are accelerated to the same potential difference. This V value somehow you will get. This work done will be converted into energy. Means this energy can be written here like this, under root 2m charge of the charged particle into potential difference divided by QB. Now this formula which we got, here the masses we can compare, charge is same, potential difference is same, magnetic field is same. It means you can directly say R is directly proportional to root m. R is directly proportional to root m. Radius is directly proportional to root m. Yes, we can say now, because rest all the things are constant. If you will divide also, all the things will get cancelled. So the radius of A, first P particle is A, directly proportional to under root of its mass is m1. The second particle radius is B, directly proportional to m2. Just divide them. A by B will give us under root m1 by m2. We need the m1 by m2 ratio, so just take the square. m1 by m2 will give you a square by b square. You will be getting C option. Okay, clear? So this is a good question. Definitely, if you will cram the formula, you will not be able to solve it. You have to just use your brain very cleverly. Next, we are having this particular fifth question. A galvanometer of the resistance, this is done? Yes. A galvanometer of the resistance G, again a good question. A galvanometer of the resistance G is converted. So we are having a galvanometer having resistance G. We want to convert it into ammeter, and we want the range 0 to 1. That is the maximum current which can pass through the ammeter is 1 ampere. Yes. So we want this galvanometer to be converted into ammeter of range 0 to 1 ampere if the current through the galvanometer is 0.1% of 1 ampere, the resistance of the ammeter is. So if you want to design ammeter through galvanometer, we all know that we have to connect a shunt resistance in the parallel. Yes, a shunt resistance. The current, that maximum current allowed to pass through galvanometer will be Ig, and that is given to us. The current through the galvanometer is 0.1% of 1 ampere. So can we find Ig value? 0.1%. Matlab 0.1 upon 100 into 1. Yes, you will be getting 1 upon 1000. That is 1 milliampere. That is Ig. So Ig value we got it, 1 milliampere. Okay. Chalo. Now this what we designed over here is our ammeter. This is our ammeter, beta. है ना? This is our ammeter. What is the range of ammeter that we wanted? We want the range of the emitter should be maximum current which can be passed through the emitter is 1 ampere. When this 1 ampere current is passing, the maximum allowed current is 1 milliampere. How much current will go through here? This through this branch, we can easily apply junction rule. 1 ampere, I am just making a little changes here. 1 ampere, can I write it as 1000 milliampere? Why I am writing it like this? So milliampere calculations will be easy for me. Okay, so 1000 is coming here, 1 is going here. It means 999 milliampere will go from this branch. Mark this point as A, this point as B. Now, simply we all know how we can find the shunt value. Can we find the shunt value? Do we need the shunt value in this particular question? No, beta. This is a simple mistake a student can do. That is, the resistance of the emitter is asked. What is the resistance of this emitter? Resistance of emitter will be parallel combination of shunt and G. That is shunt into G divided by shunt plus G. If you made mistake, let's say you have not found this particular value, you have calculated shunt. CBSE is having a stepwise marking, beta. We all know that CBSE check the questions stepwise. Okay, so shunt, definitely we have to calculate the shunt also. So shunt here is, how can you find the shunt? We can find the shunt value by equating the potentials of A, B point. VAB, here and here, parallel potentials will be same. So you can write, for the upper wire, the potential will be the current through the wire, milliampere, into the resistance of the wire, S. Acha. In the lower wire, potential difference can be written as the current through the wire, 1 milliampere, into the potential, into the resistance, that is G. Milli will get cancelled. The shunt value will be given as ampere will also get cancelled. Shunt value will be G upon 999 ohm. This is the shunt value that we are getting. G upon 999. Once you will get it, just click it. Don't do it, okay? Just have patience. You have to see, beta, you have to have the patience. You have to check the answer, the question, read it again, go through the question again, that whether we are doing it correct or wrong. Okay, is there anything missing? So the important thing here is the emitter resistance. So the emitter resistance will be, just do the parallel combination, G upon 999 into G upon S. S is G upon 999 plus G. Now G you can take outside, do the calculations, you'll get the answer. Just do it. G square upon 999 upon G you can take outside, 1 upon 999 plus 1. Okay, stepwise I am doing. So you will be getting this G value will get cancelled. G upon 999 divided by 999 plus 1, 1000 upon 999. So the value here is G upon 1000. This will be the final answer of the resistance of emitter, beta. Okay, which is asked. First option is resistance of shunt that we need to connect here. Okay, the shunt resistance that we need to connect here. So this is the question number 5. Next, question number 6. 10 centimeter long wire lies along y-axis. So we are having a wire which is lying along y-axis like this. Okay, so this is a y-axis. Chalo. The current carries a current of 1 ampere in the positive y direction. So this is the direction of current. I value is 1 ampere. Direction is j cap. Magnitude is B. B value is given as, we cannot draw B value because it is a little bit 3D figure. It will become a 3D figure. 5 milli j cap. Tesla I am taking outside, minus 8 milli k cap. Okay, this is the value of B. Okay, the force on the wire. Now we have to find the force. Definitely if the wire is having current and is placed in the magnetic field, it will experience the force and the value is BIL sin theta. But if I apply the formula BIL sin theta, that will not be helpful here. Why? Because you can easily do this question by using the cross wala formula. Okay, the vector formula. The force on the wire placed in a magnetic field can be given as current L cross B. Now what is the length vector? What is the direction of length vector, beta? Whatever is the direction of current is the direction of length vector. So length here is given as 10 centimeter na, so it will be 10 centimeter and its direction will be the direction of current, that is J cap. Got the length vector? Place it over there. So the current is 1 ampere. The current is 1 ampere. Length vector is 10 centimeter. 10 into 10 ki power minus 2 J cap crossed with the magnetic field 5 milli J cap minus 8 milli K cap. Okay, sure. Now do the cross product. This term will be crossed with this one, then this term will be crossed with this one. J cross J, 0. J cross K, I. So it means we'll do this one. 1, then 10 with the power minus 2, you can write it as 10 with the power minus 1, multiplied with minus 8 into 10 with the power minus 3, multiplied with J cross K. J cross K. Clear? Chalo. Got the answer? This one will give you 0.8 minus J cross K will give you I cap. And milli also. We left with the milli. Let us write the milli also. 10 with the power minus 3 milli I cap. So this will be the final answer, 0.8 milli I cap. And the unit of the force will be Newton. So if you look carefully, this one, B option, 0.8 milli Newton I cap. Okay, so option number B will be the correct answer for this particular question. Okay, let us move for the next question, that is question number 7. So are you finding it difficult? Ma'am, when you will solve, a question paper will become very easy. But when we will solve question number 7, the primary and the secondary coils of the transformer have turns. Primary turn 500, secondary turn 5000. Then primary coil is connected to the AC source. So this is the primary coil, less turns, secondary coil, more turns. Transformer. Primary coil is connected to a source, 220 volt AC, 50 hertz frequency. Output across the secondary coil. We have to find this out. What is this output? Number of turns here is secondary is 5000 and the primary number of coils are 500. Can you find the secondary voltage? Can you find the secondary voltage? Whether the potential this frequency will change. This is a frequency changer. No. Transformer. Step up, step down, voltage or current. Power will change. Input, output. If the resistance, the wires are having the resistances. But the frequency will not change definitely. The frequency 50 hertz. Here also the frequency will be 50 hertz only. Okay? Clear? If the frequency will change, then how we will design a rectifier? Now, 50 hertz will be the final frequency. Can you find the ES? NP upon NS is equal to EP upon ES. So, ES value will be EP, primary voltage 220 volt into secondary turns 5000 divided by 500. Okay, just solve it. 10, 2200 voltage. Step up transformer. Voltage will be stepped up. D option. Easy? Very easy. Transformer questions from the chapter, this topic transformer, all the questions in this particular question paper are very easy. Then we have next question, that is 8th question. What is the 8th question? The first scientist who produced and observed, the electromagnetic wave of wavelength range 25 millimeter to 5 millimeter. See, by looking at the wavelength, you have to check that in which, what is the range, what is the wave in this particular range. So the wave here is radio wave. Okay, the wave here is radio wave. Now the radio wave was first produced and observed by scientist Hertz. If you read the NCERT, definitely you can easily do it. Okay, but anyways, it is a static data based question. If you know it, you will solve it, otherwise you will not be able to solve it. then this Jai Mata Di wala system we have to do it. Okay, in pin, safety pin. Next, a wave associated with the moving electron and a moving proton have the same wavelength lambda. So we have waves associated with electron and proton. Okay, having the same wavelength lambda, that implies they'll have same what? See, electrons or protons are particles, yes. So the wavelength associated with them will be, we'll use the de Broglie's wavelength, that is lambda is equal to h by p. Now they'll have same, definitely if the electron and the lambda of the proton is same, then this momentum of electron, momentum of proton, momentums will be same. Yes, if the lambdas, the wavelengths are same. The rest all the terms you cannot comment beta by looking at this particular formula. Yes. Next one, question number 10th. Two beams A and B use whose photon energies are, very easy question. Two beams A and B, photon energies are this one and this one. Okay, the energy of the photon. So the first beam is having energy 3.3 electron volt and the second one is having energy 11.3 electron volt. Yes, illuminate a metallic surface having work function. Both beams are illuminating a metallic surface. The work function of the metallic surface is 2.3 electron volts successively. The ratio of the maximum speed of the electrons emitted by beam A to that of beam B. So we have to find the ratio of the kinetic energy of the electron, maximum kinetic energy of the electrons emitted. We know that whenever the electron will emit out with certain kinetic energy, then from the total energy, some energy will go into the work function, the rest it will use for gaining the kinetic energy. Yes, the photoelectron. So for the first particle, we can write half into the electron which is coming out with this kinetic energy, then mass of the electron we have to take, velocity of the first electron with the first beam, v1 square is equal to, first energy is 3.3, work function is 2.3, keeping it in electron volt only because this unit will get cancelled out later on. So 3.3 minus 2.3 will give us 1.3. Sorry, 1 electron volt. Okay, 1 electron volt. So we are getting half mass of electron velocity square as 1 electron volt. Point number 1. Second beam, second energy. So kinetic energy of the electrons emitted by the second beam will be the second beam's energy minus the work function. Second beam's energy is 11.3 minus 2.3 in electron volts. We will be having 9 electron volts, half mass of electron, velocity with which they will come out. The velocities will be different definitely, mass of the electron is same. So you can divide these two equations to get the ratio of the velocities. So the ratio of the velocities, maximum speeds, this is the maximum speed only. So we'll get to V1, this half ME will get cancelled. V1 square by V2 square will be equals to 1 by 9, and electron volt is also getting cancelled. So V1 by V2 will give us the answer as 1 by 3. Option number C. Okay, done hai? Sure. Next one, then we have the transition of electron from the transition of electron that gives rise to the formation of second spectral line of the Balmer series. See, Balmer series was not mentioned in the book, in the new syllabus, so I was a little bit confused, but I know that you all have covered the Balmer series in chemistry also, if I'm not wrong. Yes, so Balmer series you must have covered in the chemistry. But anyways, this was a simple 1 mark question. What we have to find, the only simplest question on Balmer series is this one. So what you can get, we all know that the Balmer series, from the higher energy levels, if the electron is falling from all the higher energy levels, if the electron is falling on the second level, then whatever wavelengths will be emitted, whatever wavelengths, whatever spectrum you will get will lie in the Balmer range. Okay, will lie in the Balmer series. Okay, this is the Balmer series, beta. This is the Balmer series. Acha, then they asked that the second spectral line we got. So now understand carefully. If we have this one from n is equal to 3 to n is equal to 2, when the electron will fall down, some energy it will emit. That energy you can see on the screen as a line. Then that will be the first spectral line. Then from n is equal to 4 to n is equal to 2, when electron will fall, you will have another wavelength, that is that will give you the second spectral line. Yes, so the answer here will be the final energy level will be second and the initial energy level will be fourth. Final will be second and initial will be fourth. Clear? So this will be the correct answer. Option number C. Chalo. Next we have germanium doped with arsenic due to doping. What will happen? Germanium doped with arsenic. So germanium doped with arsenic is n-type. Yes, arsenic is n-type, 15th group element, extra 5th electron, 4 electrons will be combined, 5th electron will contribute towards the conduction. So the number of conduction electrons will increase. Structure will not be distorted, holes will not increase. The number of electrons will increase, conduction electron, option number B. Again easy question. So 1 mark questions are very easy. Then we have assertion reasons. First assertion reason is two long parallel wires freely suspended and connected in series to a battery move apart. Let us understand this question. This question I think came earlier also in some examination. Two long parallel wires. Okay, you have to, let's say randomly I'll give you two long parallel wires. You have to place them parallelly, but you have to connect them in series. So how will you do? So let's say you are having these two wires. So you have to connect them in series. What is the meaning of series? See, if you will not understand the meaning of series now, you will not be able to solve this particular question. Series means the current should be same through both the wires. Yes. So let's say this is the first wire, this is the second wire. Okay. I have connected them in series like this, and will connect it with the battery also. Okay. Clear? In this particular case, they are not in parallel. They are not parallel with each other. So current will flow like this. If I want them to be parallel, what I will do, I will take this wire, will place it like that. Yes. Then this battery will go there like this. So the battery will be like this. And the connection will be like this. Now these are the two wires. These are the two wires. The wire A, B, and the wire C, D. Now these two are in parallel. Yes, these two are in parallel. Okay, two long parallel wires. Okay, freely suspended. You can suspend them freely. Connected in series. Definitely these two wires are connected in series. Then they will move apart. Let us check. The current will go like this. Then go like this. Now opposite direction current. The current is in the opposite direction. So they will move apart, they will repel each other. Yes or no? When the current is in the opposite direction, check it beta. If the current is flowing in this particular direction, it will produce the magnetic field in this direction. Okay, the magnetic field is going inside. Yes, the length vector is in this particular direction. Force will be like this. So definitely they will repel each other. They will move apart. True, correct. Then the reason is the two wires carrying current in the opposite direction repel each other. Yes, correct reason. When the wires are having opposite currents, then they will repel each other. Option number A. We will go with the option number A. Reason correct, explanation correct, assertion is also correct. Question number B. 14th question. Plane and convex mirrors cannot produce real images. Obviously, they can. Can you find a case when they will produce real image? If there is a case, then we must have studied it. Chalo. The virtual image cannot serve as an object to produce real image. See, whenever we have an object and we have a real image of it, that real image will work as a virtual object and some other image will be created through that virtual object. That concept we have studied now. A virtual image beta cannot serve as a object to create a real image. This cannot be possible. So again, this is true, but the explanation is not This is not the explanation of this question. So we'll go with the option number B here. Next one. Mutual inductance between the two coils is maximum. So we have one coil like this and the second coil. How we'll place the second coil, we'll get the maximum mutual inductance. Mutual inductance maximum means maximum flux should pass through the second coil. So if we'll place the second coil coaxially like this, so maximum flux will cross through the coil. Yes, the mutual inductance between the two coils is maximum when the coils are wound on each other. Correct? The flux linkage between the two coils will be maximum when they'll wound on each other. Correct? Correct explanation, option number A. Next. In photoelectric effect, the kinetic energy of the electron emitted increases with the increase in the intensity of the incident light. Is it? Intensity can change the number of photoelectrons, but the kinetic energy of the photons, of the electrons, depend on the frequency of the incident photon. So this is wrong. Photoelectric current depends on the wavelength of the incident light? No. It depends on the photocurrent depends on the intensity of the incident light. So both are wrong. You can go with option number D. Next, section number B. Question number 1, 17th question. A uniform wire of length L, area A, has resistance R. So let us consider a uniform wire and the length is L, area is A, resistance is R. R value can be written as, you can consider its resistivity to be rho L by A. Then the wire is uniformly stretched so that its length increases by 25%. Length increases by 25%. So you stretch this particular wire and the new length is the old length increased by 25%. So the new length can be written as old length plus 25% of old length. Yes, clear? So the new length can be written as 125 divided by 100 times L. Clear? This is the new length we got. You have to find the percentage increase in the resistance. Percentage increase in the length is given. Percentage increase in the resistance is asked. So how will you find the resistance? Percentage increase beta. How will you find? This is the new length. This was the old length. There are so many direct formulas. I'm not applying. I'm solving the paper according to an average, below average student. So I'm trying to solve each and every step as much as I can. This is the old value. This is the new value. Hai na? So if I'll take over here, so new minus old, what will be left? 25 by 100 into L will be left. Correct? Divide with L. Divide with the old value. What will be left? 25 by 100 will be left. Yes. 100 take on the left side. Take the 100 on the left side. You'll be having into 100 and you'll be left with 25. Yes or no? Percentage increase is new minus old divided by old into 100. Formula we all have already studied. Percentage change you can easily find by this particular formula. So we'll find the resistance percentage also by this particular formula. Now we have to find first the area, the new area, A dash. As we are stretching the wire, area will be different, but the volume will remain same. Yes. So you can say this and this volume. Length, old length into old area will be equal to new length into new area. Yes sir, correct? So now the new area can be found as old length into old area divided by new length is 125 divided by 100 times old length. So this will give me the value of new area as 100 divided by 125 into old area. This is the new area. So new resistance can be written as, resistivity will remain same, na, material is same. New length divided by new area. New length is 125 divided by 100 times old length. New area is 100 divided by 125 times old area. So you'll be getting it as 125 divided by 100 whole squared, and this will give you rho L by A. Clear? Okay. This rho L by A is the old resistance, so you'll be getting 125 divided by 100 whole square into old resistance. Okay. 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 Done. Chalo. Now this one we got. This is the new resistance in terms of old resistance. I'll apply this particular formula which I have written over here to find the percentage change in the resistance. So the percentage change in the resistance can be written as percentage change in the resistance is new value of the resistance minus old value divided by old value into 100. So new value is 125 divided by 100 whole square into R minus R divided by R into 100. R will get cancelled from numerator and denominator. We will be getting 125 divided by 100 whole square minus 1 into 100. Will give you the percentage. So just calculate it, beta. You will get the answer as this will be 15,625 divided by 100 and the square of it minus 1 into 100. So you'll be getting it as 5625 divided by this value into this. So we'll be getting the answer as 56.25%. So that will be the percentage increase in the resistance. Clear? Next question. 18th question. An object is placed 30 centimeter in front of a concave mirror of radius of curvature 40 centimeter. So there is an object which is placed in front of a concave mirror. So this is a concave mirror and we place the object at 30 centimeter and radius of curvature is 40. Okay? So radius of curvature, center of curvature is 40, means focal length will be 20 and the object is placed in between 30 over here. So whenever object is placed between radius of curvature and focal length, the final image will be beyond center of curvature. Now this is F, this is C. So final image will be beyond C. So we'll find the final image. The U value here is, the incident ray will go like this. So the measurement of the U, if you will start from pole, you have to move opposite to the incident radiation. So we'll take it negative, minus 30. Yes, minus 30. Now, focal length is also minus 30. You have to move like this, minus 30. Okay? Sorry, 20. Focal length is 20. So focal length will be minus 20 centimeters. U value will be minus 30 centimeters. 1 upon V plus 1 upon U is equals to 1 upon F. So this will give you the value of 1 upon V as 1 upon F minus 1 upon U. Put the values, get the answer. Beta, it's very, very easy. V value will get it as minus 60 centimeters. Okay, so somewhere over here in this particular direction, the V will be minus 60 centimeters. Okay, now second part we have to find the position we have seen, magnification of the image. So to find the magnification of the image, again direct formula based question. Magnification value will be minus V by U. Minus of V is minus 60, U is minus 30. So we'll be getting it as minus 2. Magnification is minus 2. It means that the image is magnified, double as that of object, and minus sign shows the image will be inverted. HI upon HO, opposite signs, minus. So done. Okay, chalo. Next question. We are having 19th question. Consider a neutron of kinetic energy E and a photon of same energy. So we have to consider two different dimensions. Okay, one is a neutron having kinetic energy E. So neutron's kinetic energy can be written as half mass of neutron into velocity of the neutron whole square. I think we will not need it. Chalo, anyways, so energy of the neutron is this one, En. Okay, they said that the wavelength associated with the neutron is lambda and the de Broglie wavelength. Okay, so the wavelength associated with neutron can be written as h by momentum of the neutron. That is h by momentum of the neutron. Very careful. Energy is given. So we have to write the formula in terms of energy. So it will be h divided by under root of 2 times mass of neutron into energy of neutron. They have given energy of neutron is E. Okay, consider the neutron of mass m, and kinetic energy, mass of the neutron we have to consider m, kinetic energy is E, and the photon of the same energy. So we have to consider a photon, and the energy of the photon is, we know it is h nu is equal to hc by lambda of the photon. Yes, these two energies are equal. Energy of neutron is equal to energy of photon. This thing is given. So once this thing is given, we have to find the expression of lambda n by lambda p. So can we find lambda p from here? Lambda p value can be written as hc by energy of photon. Both the values equal to E. I'll place E over here in the formula. So we have to find lambda n by lambda p. Just take the ratios. Lambda n by lambda p will be equals to h upon under root of 2 mass of neutron. Energy is E, I am placing it E. Mass of the neutron also it is m, we have to place it as m only. Divided by energy of the photon is, lambda of the photon is hc by E. Yes, this value is equals to E. Now just take the ratio. You will be getting the final answer as E upon C times under root of 2me. So this root E and E will get cancelled. So you will get root E on the numerator. So 1 upon C times under root of E by 2m. This will be the final answer. Okay, chalo. Done. Next question. 20th question says that a monochromatic light of frequency. We have a light of frequency value is 5 into 10 with the power 14 hertz. Passes from air into the medium of refractive index. So we have a medium over here, and this light ray is passing into the medium. Okay. Find the wavelengths of the light reflected and refracted at the interface. So one light is reflected and one light is refracted. This is the incident light. We know that if the light is incident, the properties associated with the incident light will be its frequency, its wavelength, and its speed. Whatever speed here, the same speed will be, the reflected light will also have same speed, same wavelength, same frequency. All the parameters will remain same for the reflected light. But for the refracted light beta, only the frequency parameter will remain same. Lambda will be different. The velocity will be different. Yes. So now we have to find the lambda for reflected light and the lambda for refracted light. So we know that the lambda of incident light will be equals to lambda of the reflected light. Okay. So let us find the lambda of incident light. Lambda of incident light will be lambda is equals to C by nu. C is 3 into 10 with the power 8 divided by nu is 5 into 10 with the power 14. Clear? So we'll be getting 0.6 times into 10 with the power minus 6 meters. You can write it as 0.6 micrometer is the lambda of the incident radiation. This is the wavelength of the incident radiation, will be same will be the wavelength of the refracted radiation, 0.6 micrometer. So for the first part you will be having the answer as reflected one will be 0.6 micrometers. Okay? Then a refracted light beta, refracted light, Snell's law we have to apply. Snell's law says sin I upon sin r is equal to refractive index of the medium equals to wavelength of the light in air divided by wavelength of the light in the medium. If you are writing the refractive index of the glass with respect to air, this is the formula. Yes, it means we know that the wavelength, more general you can write the refractive index is equals to wavelength of the light of the incident light divided by wavelength of the refracted light. Refracted will enter into the medium, na? So the wavelength of the refracted light will be lambda of the incident divided by the refractive index of the medium. So incident radiation is having 0.6 divided by this value is 1.5 micrometer. So this will give us the final answer as 3 2s are 3 5s are. So you'll be getting 0.4 micrometer. Okay, 0.4 micrometers. So the refracted wave will have the wavelength 0.4 micrometers. Done. Next one. B part. A plane convex lens, plano-convex lens of focal length. A plano-convex lens, ma'am, I've considered this one. Fine. It's also fine. A plano-convex lens, you can place it like that also. Focal length is given 16 centimeter. Is made of the material of refractive index 1.4. The mu value is given to us as 1.4. Clear? Then what we have to find? Calculate the radius of the curvature of the lens. This one, this curvature we have to find. If we are considering this incident radiation, means we are looking from this particular side beta, then this will be our first surface, this will be our second surface. Yes. So the formula here, we will use the lens maker's formula, which is mu minus 1 upon the radius of curvature of the first surface which you are facing, first surface, then the radius of the second surface. Focal length is 16, refractive index is 1.4. The first surface radius of curvature we have to find. The second is a plane surface, its radius will be infinite. So 1 by 16 is equals to 0.4 times R1. Clear? So R1 value will be equals to, is equals to 16 into 0.4. Can you find it? Just do it. In centimeters, you'll get the answer in centimeters. So we are done with all the questions. Then we have to differentiate between diffusion and drift current. Completely theoretical question. After that, we are having section C and section D. I'll make a separate video on section C and section D. Okay. So we'll try to finish section C and section D. We'll send the videos of section C and section D also. Chalo. Thank you, beta. Thank you so much.